I'm Anil Kumar, and this is a very important video to understand periodic functions. As you know, periodic functions may or may not be represented by sine wave. Heartbeat, for example, is a periodic function, chirping of insects. In nature, you may see so many things happening periodically. All those are periodic functions since their cycle is being repeated at regular intervals of time. Now, one of the most important periodic function is the sine wave, and in this video we'll try to produce one and understand a sine wave, and in later half we are going to investigate sine wave in more details. Let's consider a point on a circle. So I've already drawn a circle for you, so we'll represent a sine wave with the help of a point moving along the circumference of a circle. So let us assume that there is a point right there on the circle and it moves along the circumference in counterclockwise direction. Let us say that the point is in this position now, where it makes an angle of theta with the x-axis. Let me say this is my x-axis. Let me just extend it. Okay, this is my x-axis and that is y-axis. We are assuming that there is a point which rotates counterclockwise along the circular path with radius 1 unit. So this is 1, this is minus 1, right? So this will be minus 1, this will be 1 unit away. Now we are also making one more assumption, that is this circular point, this center itself, is moving at a constant speed along the x-axis. So we are also assuming this. That means what is happening is that this point, as it moves along the circular path, the center of the circle moves towards the right, and therefore what really happens is that we generate a wave, and that wave is the sine wave, which we will be talking about. So let me sketch it and then we'll describe it. So these lines will guide me to restrict the wave within a particular interval, which is going to be from 0 to 1 to minus 1. So we'll get a wave. This is the set of points In fact, this wave represents the height of this point from the x-axis as it rotates counterclockwise at a constant speed, and the circle itself moves towards the right at a constant speed, right? So here we have a couple of things going on. One, we have the center of the circle, let me say center of the circle, moves horizontally at a constant speed. Second, we have a point. Let me call this point's position as x and y at any given instance. A point rotates along a circular path with unit radius in counterclockwise direction. So these two things are happening simultaneously, and what we are observing is height, or you can say the y value of the point from x-axis. That is what we are observing, and this is what results into a sine wave. In short, that is what we're trying to say here, right? So So what we have here is a point which is moving counterclockwise as the circle. You can consider this to be a wheel which is moving horizontally, right? In that case, height of the point can be plotted as these set of points, which will result into a wave which we are calling as a sine wave, right? So I hope now everything has come together, right? I've also placed all this in the form of a statement here, which says sine function can be represented by the height of a point y as it rotates counterclockwise along a unit circle while moving at a constant speed along x-axis. I hope now you can understand what I'm trying to say. Now the question here for you is, in this particular situation, what is the independent variable and what is the dependent variable? And when we say that sine wave is produced, how can we represent it in the form of an equation? So you can now pause and answer these questions. My suggestion is that in this particular case, I will take independent variable as the angle of rotation. So for me here, let me just, because I have very limited space, so I'll just overwrite on whatever I've done here. So what I'm saying is that the independent variable is angle theta of rotation. The dependent variable is, for me, height, which is y in this case, right? And what I'm saying is moves constant speed. Those I will say conditions, or at times we will say assumptions. So the assumptions are that everything which is happening at a constant speed or regularly, correct? Without any other influence. So whatever is going on is just going on forever. So those are the conditions and assumptions, right? Now, how to write the equation? To write the equation, we can consider this to be a right triangle, right? If I drop a perpendicular, it becomes a right triangle, right? Now in this right triangle, this height, the x value is the horizontal distance, y is the vertical distance. Now in this case, r, the radius or the hypotenuse, is equal to 1. What is y related to in this triangle with the other two sides? Sine theta, as you know, is, okay, let me write in between. Sine theta is opposite over hypotenuse. Is it okay? Now in this particular situation, opposite is equal to y and hypotenuse is 1. Therefore, from here we can write the equation y equals to sine theta. Do you see that? So from the very basic definition itself, we do get the equation which relates our dependent variable with the independent variable. Do you see that? So that is sine function. It is so basic in nature. I hope you understand and appreciate this part. And now we'll explore this. And therefore, in most of the examples which we'll be considering for modeling of periodic functions, we'll land up with writing an equation which will be involving sine function. With this video, I think and hope you can appreciate the whole concept, right? And from here, you can get a whole lot of properties for the sine function. I would like you to pause the video and write all the characteristics which you could from this given scenario, right? One could be that the maximum value for this could be 1, minimum is -1. Domain is all real numbers since it goes on forever. Range is from -1 to +1. Periodicity is what? Periodicity is circumference of the circle, right? That is the periodicity, 2 pi r, correct? Therefore, in this particular case, the periodicity will be circumference. Very important. So periodicity is equals to circumference, which is 2 pi r. Now since r is 1, it has to be 2 pi. And that is why in most of the cases you get 2 pi as period of a wave. When we talk about angles in degrees, then this whole rotation is 360 degrees. So in degrees it will be 360 degrees. You get the point. So after every 360 degrees, that is the rotational angle. After 360 degrees of rotation, it again repeats, correct? Then theta is our independent variable, correct? Y equals to sine theta is dependent on theta, and here the time period for us is 360 degrees or 2 pi radians. Do you get the point? So that sums it all, right? And further, we're going to explore this function in the coming videos. But the whole idea was for once to share with you from where the sine wave comes and how come in every example when we are trying to model a periodic function, we'll end up writing equation relating to sine wave. I hope you understand and appreciate it. Thank you and all the best.